Hello everyone. Today we are diving into a exciting Python project that simulates the distances between planets in our solar system. Using basic astronomy, trigonometry and Python programming, we have created a program that calculates the positions and distances of planets relative to each other over time, introduces some realistic noise into our measurements, and analyzes these distances to find patterns and insights. First, let's talk about the distance between Earth and Mars on day 732. Using our simulation, we found that the distance is 6.5 million miles. This calculation is based on the planet's orbital path, assuming circular orbits for simplicity. By calculating their positions in their orbits on day 732, we can determine their relative distance in space. Our position function calculates a planet's position in its orbit based on the day of the year. It uses trigonometry, specifically the sine and the cosine function, to determine x and y coordinates of the planet. Assuming a circular orbit, the distance function then uses these coordinates to calculate the Euclidean distance between any two planets, applying Pythagorean theorem. These functions are fundamental for simulating the planet's movements and interactions over time. We generated a 1000-day time series to simulate the distances between Earth and the other planets, adding Gaussian noise to introduce realism. The noise simulates observational errors. By plotting these distances, we can observe periodic patterns that correspond to the planet's orbits around the sun. Interestingly, when we increase the standard deviation of our noise, the average distances remain consistent, but the data's variability increases. This observation underscores the robustness of average measurements over long periods, despite short-term fluctuations. To deepen our analysis, we formed an 8 into 8 matrix representing the average distances between all pairs of planets over 1,000 years. This comprehensive simulation considers each planet's orbital period, providing a detailed view of interplanetary distance over time. By averaging these distances, we can identify which planets are generally closer to or further from each other, offering insights into the dynamic layout of our solar system. In conclusion, our simulation reveals fascinating aspects of planetary distances and their patterns over time. Notably, the closest planet to Earth in this 1000-year average may differ from what we typically expect, illustrating the complex and dynamic nature of our solar system. This project not only showcases the power of Python for scientific simulations, but also deepens our understanding of the cosmos that surrounds us. Thank you for joining me on this journey through space and code. So now I'm gonna run the code and show you the outputs. So here you can see the distance between Earth and Mars on day 732 is 6.5 million miles. And here you can see the plots as well. And you can also see the average distance matrix.